increasing, decreasing, or constant function here. Reading that information, what it's asking you to do is pick an x value and pick a y value. So you'd have a picture of a graph, and you pick an x, and then you pick another x, okay? And you're supposed to find their outputs. Where are the outputs for these particular x values? And as you move from one to the other, what's happening to the output? Well, if the output for x1 is smaller than the output of x2, the function is increasing. So the math mumbo jumbo, I call it, I think, you know, it gets a little bit confusing, but that's how you're supposed to read this. Pick an x, pick another x. Where's the first output? Did I go up or did I go down as I moved to the second output? So here's a function. They're telling us it's x cubed minus 12x. To speed this up, can you pull down to the bottom so this stuff pops up? Touch the bottom. Thank you. Okay, can somebody read? I forgot what it was already. X cubed minus 12x squared?
No.
Just 12, just like that? Okay. Zoom standard. Okay, so, oops.
Stretch that.
Oh, need a little more.
Make the x-axis up 5.
I need to just get y value. Okay, so this is what the picture looks like. If I go second, trace, which takes me to the calculate menu, we've done intersections a lot. I'm going to look for a maximum first. And so here's my cursor. I'm going to find this maximum, the curve on the left. So I'm going to move my cursor up and over the top of this. I'm going to hit enter so that I'm on the left-hand side. Now it's asking, go to the right-hand side of that, and we can go up and over. And I hit enter there, and then it says guess, and that's, again, not the game. It just says whatever. So it tells me I'm at -2, 16. Okay? So this point is -2, 16. And we'll put the cookies in the oven and pull them out right away. This one over here is +2, -16. Okay? So those are the two maximum minimums, and you can practice finding them if you'd like to try that. So what we need to do is figure out where this graph is increasing or decreasing and all this. So what I want you to do is exactly what I did, and then we're going to bring those x values. So this x value is -2. And I'm just going to put it right there. And this x value is +2. I'm going to put it there. Because when you report where the function is increasing or decreasing, you use the domain, which is the number line or the x-axis. Okay, so we report from here to here on the x-axis, and from here to here, from here to here. So I bring those important pieces down on the x-axis. So the math mumbo jumbo was, let's pick, this to be my first x. Where is the output? Somewhere down here, right? Yeah. Then we'll pick this x. Its output is up there. So as you go from the first blue dot to the second blue dot, what did it do? It was an increasing, right? This is -30, this is 8. So I went from -30 to 8, so the y values increased. So we're going to go all the way up to -2, the graph is going up. So that's an increasing function. Where did it start? What's way over here? So we start way on the left at -infinity. We come all the way into -2. The graph was going up. What's happening between -2 and 2? You know, the first one, you could start at this green dot, and you're going all the way over to 2, which would be the red dot. So what happens from green dot to red dot? It's falling. And so that's -2 to 2, decreasing. And then when we start at 2 again, and we move out to the right, the graph's starting to go back up. And it goes all the way out to infinity. So when somebody asks you for the intervals, which is increasing or decreasing, do your work along the x-axis. I get a lot of students go, hey, it's increasing from -infinity up to 16, decreasing from 16 to -16, and increasing from -16 to infinity again. You're reporting the range to me. You're giving me the range. You're giving me the y values. I want the x values. Now, to be constant, up there it's a constant. Very rarely do we have a constant function. You may run into some if you would look in the book. That part of the graph is constant. You would have to see a horizontal line. It has to be exactly horizontal to be constant. So very rarely do we run into it. Even U-shaped graphs that really flatten out are never constant. Okay? Also notice I did not use any square brackets. Okay? You can't, a number cannot be in both the increasing and decreasing interval. Right? So these endpoints, because they're shared between intervals, we use parentheses. You can't be in one without being in another, so they're not in either of them. So parentheses. So, another thing here with a bunch of math mumbo jumbo down here, relative mins, relative maximums. What is the maximum up here? What's the maximum output? What?
Oh no.
Maximum output. The graph keeps going up forever, right? What's the minimum? Keeps going down forever also. But when they talk about relative max or mins, mathematically those are things that are important. Right here is called the relative maximum. This is called the relative minimum. These changes in directions, the bumps, the peaks, the valleys. And you can find those by doing second trace, calculate minimum or maximum, and you move around and find them. So with somebody sitting near you, I want you to type in, for number 4, type this in. Just for practice, we're going to see if you can find a minimum or maximum. In this case, because it's a negative out front of the quadratic, it's opening down. So find the maximum. Do that now. Negative 3x squared minus 2x plus 1. Zoom standard. So you should have a little parabola right here. You go second trace to calculate your, in this case, maximum. And when it says left-hand bound, don't try to hang out too close to the peak of this thing because just you got to be careful. So I always kind of exaggerate. I'm making sure that I'm down a little bit on the left. Get back up and over to the right-hand side. And then just hit enter. Now you're getting 0.3333 and 1.333. So if you know anything about fractions, you're talking about 1/3, comma 4/3. The x is negative. So that is your relative maximum. We're not going to do this one either because
It's too easy.
it's the exact same thing. You know, I'll just explain what the point. You know, this is a cubic, so it's going to maybe do something like this. Let's say, right? Now, if you know anything about economics, and you're talking about the profit of a company. Going to a business and whatnot, there are equations, and you would do calculations to figure out, you know, price points, like how much you should sell an item for. So if this was my profit line, could I say, do you think I could walk into a business meeting and tell people we have unlimited potential? We can make as much money as we want. No. There's some point out there, right, where I can charge a certain amount of money for something and lots of people will buy it and I maximize my profit. So the maximum is really going to occur at this relative, right? So you're supposed to type this in and find that thing. I can't just make 1,000 of some product or like iPhones, right? I can't just put millions and millions of iPhones out there because what's going to happen? How old were you guys when the... I gotta pause this one. Okay, we're back to this now. We don't do anything with this one, but the greatest integer function. And I believe you'll see it in some textbooks. Like that. It might be like a double bar on the side with a kind of a ceiling, if you will, over the top of it. The greatest integer less than or equal to x. The greatest integer less than or equal to x. One of the best examples that I can use for what is the greatest integer function is. I don't have it written down. I think I did over there. It's like June 6th. Isn't June 6th graduation?
Yeah.
Thursday, January 6th? Or June 6th.
On backwards.
What grade are you in? Okay. So I walk up to you, or you're at a family reunion. Better yet, you're at the family reunion June 5th. Wednesday, June 5th. Tomorrow's graduation. Wednesday, June 5th. Uncle walks up to you and says, hey, I haven't seen you for a while. What grade are you in? What do you tell him? Are you tempted to say I'm a junior at Hopkins High School, or what do you say on Wednesday? Are you tempted to say I'm a junior? No.
No.
When? What day do you get to say I'm a junior at Hopkins High School? No. No.
First day.
Friday.
Friday.
The Friday after graduation, right? The Friday after graduation, everybody moves one notch. Sophomores finally get to say I'm a junior. Juniors finally get to say it's my senior year coming up, right? And the seniors graduated, they're done. But you don't dare say I'm a junior until graduation is happening. Okay? So you don't get to achieve the next level until you are actually at that point. So According to the greatest integer function, what is 2.1?
Oh, 2.
According to 2.5, plugged into the greatest integer function, what's the output? According to 2.9 being plugged into the greatest integer function, what's the output? It isn't until you could go even 2.999 or chutes and ladders. You have to slide all the way back to 2. It isn't until you reach 3 that you get to say, I'm a 3. So, if my output is somewhere between 0 and 1, I'm at 0 for my output. Closed dot here, open dot above that number, because 0.9, 0.99, 0.999999, you don't get to claim 1. You're stuck at 0. It isn't until you actually hit the 1 that you get to move up to the next one. So you have this sort of step function happening. Negative 1.2. Here's negative 1. Here's negative 2. You got to do your number line. The numbers visually look like they're getting bigger as you go to the left, but you're getting more negative, so you're getting further away from 0, so you're actually getting smaller. So I said, here's 0, here's negative 1, here's negative 2. Negative 1.2 is right here. So which number do you slide back to? You actually have to slide back to negative 2. So negative 1.7 is negative 2. Negative 2.3 is negative 3. So when you're on the negative side, the pattern continues. Some people refer to this as a step function. So on the positive side, what I've written in blue is kind of like truncating. You're basically dropping your decimal. It's a little more difficult when you're doing these red numbers that are negatives.